Okay, how are you everyone? Good. And I'm going to start with introductions to trigonometry for the grade 12 classes. Okay, but before I go that far, I want to inform people, in case you haven't yet joined our Facebook group. I want you to go on Facebook and I want you to search for 2020 G12 of MGSS in block letters. 2020 G12 of MGSS. And I want you to click the join button, then I'll approve and the group administrators will approve. Okay. The other thing is, if you haven't yet subscribed to my YouTube channel, I will send you a link in the group. Your friends will send you links, I'll send you links, and I'll leave a link below. I want you to subscribe to the YouTube channel, and I want you to hit your notification bell so that every time I upload a new video, you don't miss out. Without wasting much of your time, let's get on to business. Okay, trigonometry. Trigonometry is a branch of mathematics that studies relationships between sides, okay, between sides and angles of a triangle. And that involves a lot of types of triangles. Okay, now that said, trigonometry come from two words, two Greek words. Okay, trigon, which means triangle, metron, which means measure. Okay, that means that all we are going to be doing is measure sides and angles of triangles. Okay, that's all we're going to be doing. Now, the first thing you have to understand, or the fundamental of trigonometry, is understanding the three main trigonometrical ratios. Okay, the three main trigonometrical ratios. Now, the three main trigonometrical ratios, okay, let me just wrap that. The three main trigonometrical ratios that you need to know, which are the basics of trigonometry. These are the cosine, okay, the sine, and the tangent. Okay, these are the three main trigonometrical ratios. Now, these three have been abbreviated with the term SOH-CAH-TOA. Okay, they have abbreviated these three main trigonometrical ratios in a statement or a terminology, SOH-CAH-TOA. Now, I want you to understand one thing. Out of the SOH-CAH-TOA comes out the three main trigonometrical ratios. I'll say that again. Out of SOH-CAH-TOA comes out the three main trigonometrical ratios. All you have to do is understand how you are going to come up with the three trigonometrical ratios using the statement or the term SOH-CAH-TOA. So, I'll start by showing you how you can come up with the ratios. So, I'll start with the first one, okay, which is SOH. So, the S is sine, okay, the S is sine, okay. So, for me to come up with the ratio, I'll say sine theta. The theta here is representing the angle given, okay? The angle given. It will be equal to the ratio. I'll get the first letter, which is O. O is going to represent opposite over H, which is what? The hypotenuse. Okay. Now, let's move on to the other one. CAH. Okay. CAH is cosine. Okay. The letter C is cosine. So say cos theta, which is the angle given, is equal to, okay, the first letter is A, which is adjacent, over the second letter is H, which is hypotenuse. Okay, let's go to the third one. The third one being TOA. Okay, the third one is TOA. Now, the T is the tangent, so it's going to be tan theta, which is the given angle, is equal to the ratio O, which is opposite, okay, over A, which is adjacent. Okay. Now, I'm sure at this moment you're wondering what opposite is, what adjacent is, what hypotenuse is. So I'm going to illustrate with you what the sides are, just to shed more light. So what I'm going to do is, I'm going to show you, or I'm going to draw a right angle triangle. Okay? I'm going to draw a right angled triangle. So I have my angle there, the right angle. And I'm going to call this A, B, and C. So let's say this side will be side A, this side will be side B, this side will be side C. Okay. Now, when you look at this right angle triangle we have here, it has three sides. Okay, it has three possible sides, and it also has three angles. Okay, we have three different angles. So we have this angle here. Okay, then I also have this angle here, and of course I have the right angled, okay, which is the 90 degree. Now I want you to look at this right angle triangle here, okay, and think about this. Let's remind ourselves the concept of Pythagoras theorem. I'm sure this you did in class 10 or grade 10 or 11. Yeah. So that's according to the syllabus. Now, A is the hypotenuse. Okay? Is the hypotenuse. This side is always opposite to the right angle, the 90 degrees. The hypotenuse is always opposite to the 90 degree angle. Okay? Now, B and C, the adjacent sides and the opposite sides. Why am I saying so? Now, I'm saying so because side B and side C will always swap in terms of how they are going to be either opposite side or the adjacent side. Let me give you an example. Let's say that, let's ignore that angle. Let's focus on this angle here. Let's say this angle has been given, okay? This angle has been given. Let me use this, there. This angle has been given, okay? Angle B has been given, meaning that B is exactly opposite to angle B, okay? Side B is exactly opposite to angle B, and side C is exactly adjacent to angle B, okay? Now, let's assume that the angle changes, okay? Let's have this angle here. Let's get this angle here. Let's assume that angle C has been given. Okay, so if angle C has been given, that will tell us that side C becomes the opposite. Okay, side C becomes opposite to this angle, and B now becomes the adjacent. I hope that is clear. So that is how side B and side C always keep flipping regarding to the angle that has been given. The angle will determine which is the opposite side and which is the adjacent side. But the unique side is the hypotenuse. It never changes. Hypotenuse will always be hypotenuse. It's always going to be the longest side of the three sides of a right angled triangle. Again, it will always be the side that is exactly opposite to the right angle, which is 90 degrees. Okay, allow me now to progress. That was just to remind ourselves. Okay, now assuming that we have been given, let's say that is 5, this is 3. Okay, we have been given the hypotenuse side as 5 centimeters and side AC as 3 centimeters. Now the question is find side AB. Okay, this becomes easy, okay, because you have been given 2 sides, which means you are going to use the Pythagoras theorem, where you say 5 squared is equal to 3 squared plus AB squared. Okay, that's what you're going to do. Then you can marry, of course. So you have 5 squared minus 3 squared is equal to AB squared. Then you can eliminate that. Okay, now you have 25 minus 9 is equal to AB. Okay, now this is very simple. Okay, this becomes very, very simple for you, and this is how we can use the Pythagoras concept. Now, assuming that I'm not really trying to focus on Pythagoras a lot, I was just trying to remind you so that you see the difference, how we have progressed from Pythagoras theorem to trigonometry. Okay, now assuming that we have only been given one side, okay, assuming that we have been given this angle here, okay, we have been given this angle here, okay, let's say 35 degrees, we have been given that angle there, okay, and we have been given side BC. Then the question is, find side AC. Pythagoras theorem will give you help, okay? It will take us the whole day for us to use Pythagoras theorem, because Pythagoras theorem only applies when you have been given 2 sides. In this case, we only have one side. So what do we do for us to get this side or that side? This is when we can now introduce the trigonometrical concept by using what we are calling the trigonometrical ratios. We said earlier on that there are 3 main trigonometrical ratios, right? There are 3 main trigonometrical ratios. Now, if we know the trigonometrical ratios and we use the terminology SOH-CAH-TOA, okay? We use the terminology SOH-CAH-TOA. How do we apply this concept so that we can calculate the possible 2 sides which we've not been given, side AC and side AB? This is how we are going to do it. So, what we are going to do is, okay, let's first of all identify, okay, let's first of all identify the angle and the sides, okay? So you can see that in this scenario, if I was to be asked to find side AC, okay, side AC, I'll have to identify which trigonometrical ratio I can apply to find the side AC. It's not any trigonometrical ratio that can apply when finding this side. Okay, so first of all, I have to identify. Okay, so if this is my angle here, meaning that this side is adjacent to this angle, okay, is adjacent to this angle. And the other angle that I have been given is the hypotenuse. Are you getting that? The other side I've been given is the hypotenuse side. Okay, now, if I've been given that hypotenuse side and I'm being asked to find the adjacent side, I have to go on my trigonometrical ratios, find which trigonometrical ratio has those two sides. Okay, I'll go on my three main trigonometrical ratios and find which trigonometrical ratio will apply, and how do I know that this is the one that I'll apply? I'll look at the two sides that I'm being asked. For example, here we've been asked to find AC, and at least I know that I have been given the hypotenuse side. So when I go to my SOH-CAH-TOA concept, I'll see that I can use cos. I'll say cos theta is equal to the adjacent side, which is side AC, over hypotenuse, okay, over hypotenuse, which is the side that we've been given. Later on, I'll proceed by saying cos 35 degrees, the theta is the angle, is equal to side AC over hypotenuse, which is 5. Okay? Which is 5. Then I can cross multiply, which means that will be over 1. Hence, I will get AC is equal to 5 multiplied by cos 35 degrees. Okay? So, in the exam, in your exam, I don't want you to leave your answer here. I want you to finish it by multiplying 5 by cos 35. Okay? Now, the other thing is, the other side is side AB. Okay? Side AB, meaning I have to calculate for that side. Now, if you can allow me, I can grab. Now, this side, I have been given hypotenuse and I have been given this angle. So, I can see that I have the hypotenuse and I have the side I'm calculating for, which is opposite to this angle. So, meaning that according to SOH-CAH-TOA, I have to look for the two sides, okay, which are in the ratio, my formula, sine. I'll pick sine theta is equal to, I'll pick sine because sine theta is going to be equal to opposite side over hypotenuse, which makes things easier for me because I'll say sine theta, okay, sine theta, which is what? The angle, 35 degrees, is equal to, the opposite is side what? AB, okay, side AB, which I'm calculating for, over the hypotenuse side, which is 5 centimeters. So again, I will divide by 1, then I do cross multiply, which will give me side AB is equal to 5 multiplied by cos 35 degrees. Okay. Now, assuming that this side has not been given, okay? Assuming that the hypotenuse has not been given, okay? And we have been given, let's say, this side, side AB, as 5 centimeters, okay? 5 centimeters, okay? And the question is to calculate side AC. So, let me just write that. So, according to this, things have changed. We have been given side AB, the hypotenuse side remains a mystery, and the question is to find side AC. Okay, that means that my angle still maintains. Okay, so I can see that side AB is opposite to this angle. and the side that are being asked to calculate for, which is side AC, is exactly the adjacent. Meaning that the only trigonometrical ratio that I can apply here is the tangent. So I'll say tan theta is equal to opposite, I'm getting the first letter, over adjacent, the second letter. Okay? So I'll say tan theta is what? The angle is equal to, opposite has been given as 5 over adjacent, which is AC. So again, I'm going to do what? I'm going to cross multiply. So I will cross multiply, and I'm going to get AC is equal to, okay, AC, sorry, multiplied by tan 35 degrees is equal to 5, okay? Because 5 will multiply with 1, and AC will multiply with that. So for me to get my actual answer, I will divide this by tan, okay? 35 degrees. Whatever I do on this side of the equation, I should do on the other side of the equation. So I will do that on the other side. Hence, that will eliminate, and I will remain with AC, giving me exactly 5 over tan 35 degrees. Okay, so with the calculator, you can punch that, and I'm definitely sure that you will get your answer correct. Okay, now that is how you can apply the SOH-CAH-TOA concept. Okay, that is the three main trigonometric ratios. That's how you can use the 3 main trigonometric ratios to solve your problems. So what I'm going to do is, I'm going to give you 2 questions, okay? Out of the 2 questions, I want you to pause the video. And I want you to solve, okay? Now, okay. Okay, so the first question that I'll give you is, okay, I have a right angle triangle. All right, let me just some marker here. So we have A, B, and C. Okay, this is a right angle triangle. Okay, now the angle has been given as 53 degrees. Okay, and 6.3 has been given as the opposite. Now, my question is, can you find the 2 sides, which is, let me just write that, find side A, side AC, B, side AB. Okay, those 2 sides. Then the next question is actually going to ask you to, let me say, calculate the angle, okay? For you to calculate the angle. Okay, let me just get that for you. Okay. Okay. If I can just rub this, I'm trying to avoid a lot of movements. Sure, you can copy that. Okay. Let me just get another right angle triangle, just like that. Okay. And you've been given that as your angle. And let me get this as 5. And let me get this as, okay, let me get this as 9. Okay. So I want you to calculate for the angle. Okay? Calculate for the angle. Now, you can change this. You can change this just for the sake of practice, or you can actually find different questions where angles are being put on a given in different aspects, maybe in that side or this angle here. So for now, I want you to find this one, okay? And then I want you to leave your comments in the comment section so that I can tend to them. I was streaming live on Facebook according to the timetable that I gave you, according to the comments that I received in the video. So if you have challenges with this, shoot in the comments, then I'll attend to the comments, to the questions on Facebook. Otherwise, these are the three main trigonometric ratios where we can use the terminology SOH-CAH-TOA. Okay, put this in your mind. Don't forget SOH-CAH-TOA, because this is what is going to help you remember the three main trigonometric ratios. Okay, if you like the video, I want you to like the video. Don't forget to subscribe to the channel, and don't forget